In this question, the power of light emitted by sun is given to us. We are assuming that sun is emitting light of only one particular wavelength, which is actually not true. But for the purpose of this question, we will assume that we have to calculate the photon flux, or the number of photons which are falling on the surface of the earth per unit time, perpendicular to its surface. The average radius of Earth's orbit is also given to us. So instead of calculating photon flux, what we can calculate is the energy that is falling on the surface of the Earth per unit time. And from that, since we know the energy of each photon, because the wavelength is given to us, we can calculate the number of photons that are falling on Earth's surface. This question is incomplete because the area of that surface of Earth is not specified. So let me just illustrate that. At the center of this, we have sun. Sun is emitting light in all possible directions. So whatever whatever energy the sun is emitting per unit time is also the total energy that is coming out of this huge sphere per unit time, because energy cannot accumulate in between. So whatever is coming out of the sun is coming out of this big sphere also, and some of that energy will fall on earth. So if this is the surface of the earth, we just have to consider the cross section of the earth. So some of that energy will fall on the surface of earth as well. That will depend on the area of earth. If the area of the earth was larger, more energy would fall, and if the area is smaller, less energy will fall. Since it is not given, the surface area is not given, we will assume 1 meter square area on the surface of the earth, which is also intensity. Intensity is energy per unit area. So what we can calculate is intensity of light at a point on the surface of the earth. So that would be the total energy, the total power, total energy per unit time, or total power is known to us. Okay, 3.9 into 10 raised to 26, that is given, this total power, and only a fraction of that is falling on this particular surface. We have taken an area to be 1 or 1 meter square area upon the area of this whole sphere, which is distance of sun from earth. This is the energy falling on 1 meter square area on the surface of the earth per unit time. Okay, P by 4 pi r square. So this is what we require. I'll call it P prime, and I can instead call it I prime if you want, or I, which is intensity on the surface of earth, which is P by 4 pi r square. So this is 3.9 into 10 raised to 26 upon 4 pi 1.49 into 10 raised to 11 square. Now this is the total energy falling per unit time. Now we know energy of one photon. Energy of one photon is hc by lambda. So we just need to calculate how many photons are there in this particular quantity of energy. Okay, so the required number of photons, flux, which is the number of photons which are falling on the surface of the earth, that will be this total energy which we have calculated upon hc by lambda. This will give us the answer. So you know h, which is a constant, c is also known, lambda is also known. You can just substitute all of that in this particular quantity and you can get your answer. I hope you understood this.